Today we're going to talk about factorials, and then we're going to start with permutations, a little bit more of an advanced counting thing. Of course, advanced to the general public, but very basic in a discrete math course. So first we need to define a factorial. In case you don't know, if we have a number n, which is a positive integer, then the factorial of n is denoted as n times n minus 1 times n minus 2 all the way down to 1. So you multiply the number by the number below and then below that until you get to 1. So as some examples here, we have 4 factorial, which is the same thing as 4 times 3 times 2 times 1, which is 24. 6 factorial is 6 times 5 times, interesting thing here, we can just write 4 factorial, since 4 factorial implies 4 times 3 times 2 times 1. Why write it all out? We can say 6 times 5 times 4 factorial. We already know 4 factorial is equal to 24, so this is going to be 6 times 5 times 24, which is 120, which 6 times 120 is 720. And the only interesting thing here about 0 factorial is that we just assume this is equal to 1. Hopefully you know factorials now, and this trick right here is very important, that you can write 6 factorial as 6 times 5 factorial, and you write 5 factorial as 5 times 4 factorial, and you keep going down until 2 factorial is 2 times 1 factorial, 2 times 1 factorial, and we just define 1 factorial is equal to 1. So this is a nice recursive definition, and this will help a lot when doing proofs with combinations later. So, let's do an application of this. How many ways can we list 7 numbers without repetition? Well, what does this mean? This means we pick some number out of the 7. So there's 7 choices for the first number. And now we have to cross that random number off. So let's say it was 4. Well, now we have 6 numbers left for the second position. Okay. Now we cross off a number, then we have 5 left, and then we have 4 left, and this is going to continue until we have 1 left. So this is the same thing as saying 7 factorial, which is equal to, I think, 49, not 49, 40, 50, 40. 5,040 combinations, or permutations, I should say. So without repetition, you can list 7 numbers in 5,040 different ways. Because the first position has 7 values it can choose from, the second position has 6 values it can choose from, because we can't use the same number twice, so on and so forth. Now what if the first 3 numbers have to be odd? Well, let's fill these numbers back in. How many numbers in this set are odd? Well, there's 4 odd numbers to start with. And then, well, we only have 3 odd numbers left. And then we have 2 odd numbers left. And at this point, we have knocked out 3 numbers. So for the fourth position, there's going to be 4 numbers available, and then 3, and then 2, and then 1. So this set right here is the number of odd numbers we can choose, and then here right here is the rest. So what is this value? This is going to be 24 times 24. If we do this, which we notice is the same thing as 4 factorial times 4 factorial, it's sufficient just to leave it like that. In fact, going any further is a little bit too much work. I believe that's 576. Might be. It looks like 576, but I might be wrong. But this is the reasoning for that. You have to first pick up your odd numbers and then the rest of the numbers after you put the remaining ones back in the pile, just because the condition is only the first 3 numbers must be odd. So what we can do is we can say, well, the number of permutations of length k from a list of n elements is n factorial over n minus k factorial, and this is the condition that there's no repetition. This is a lot of times written as p n k, or sometimes it's written as n pk, but this notation is very rarely used, and I think I only saw it in high school. Since then I have not seen anything other than this being used. So I know this is very abstract to say from a list of n elements, but what we're saying is if you have n items and you have to order a specific amount of those items that isn't the full length, then you get this formula here. So here's an example. How many ways can we list 4 numbers